All right, you guys. So our day 4 notes, I'm going to say the first 30% of these notes are review. It's stuff that we've either done in the last few days, or it's something that we've been doing since like the first week of school. So a lot of this is going to look familiar. We learned about polynomials in Unit 1. So I just went ahead, I literally copied and pasted this whole graphic from our Unit 1 notes from the very first week of school. So a polynomial is just a special name we give to expressions that's just made up of a bunch of terms. They're not equations. There's no equal signs here, right? So a polynomial just means many terms, right? And then we had special names that we gave to polynomials depending on how many terms they had. So I'm hoping you remember these words, right? So a monomial is the name we give to a polynomial of one term, mono being one. And this right here is an example of a monomial, 5x squared y. That is only one term. Remember, terms are separated by plus and minus signs, right? Not to be confused with factors, right? This term has 3 factors that make up that term, but there's no plus or minus signs. So this is all one term, okay? Then we have binomials, bi meaning 2, right? And I know this is a binomial because here's a plus sign, right? Remember, terms are separated by plus and minus signs. So 3x is one term, and then 5y is our other term. So it's a binomial. And then, of course, we have trinomials, tri meaning 3. So I have a plus sign here. I have a minus sign here, and that's splitting up my terms, right? So x squared, 4x, and 7, right? Or negative 7, I guess, right? And so that's a trinomial. So what we're going to do today is we're going to learn how to multiply polynomials, regardless of how many terms they may or may not have, okay? Now we're going to start with multiplying monomials times other monomials. You'll notice over here, I've written down that this is review, right? So multiplying a monomial times another monomial, that's exponent rules, right? That's literally what we've just been doing since last Thursday. So here we go. I have this monomial, so this is all one term, and we're multiplying it times this one. Well, I'm just going to use my exponent rules. I can multiply 3 times negative 4 because those are just, so, sorry. Those are just normal big numbers, so we just multiply them as usual. Sorry, let me color code that a little bit better. There we go. So I multiply my numbers, and then I multiply my m's, but I have 5 m's and then m cubed. And so when we multiply, we add the exponents, right? So we're going to be applying those exponent rules to our variables that have exponents. Remember, big numbers, just multiply. It is a multiplication problem. That's literally all we're doing today is multiplying polynomials together. So everything's a multiplication problem. So if it's a big normal number, you just multiply as usual. If it's a variable with an exponent, then you have to go back to your exponent rules, okay? All right, let's go look at this one. All right, so I'm literally just multiplying negative 2 times all of that. 8t to the 8th, but the only thing I can actually multiply together is just the negative 2 times the 8. So that's going to give me negative 16, and then t to the 8, v to the 4th. I'm just bringing it down, right? Because there's absolutely nothing I can do with that. Again, please remember the parentheses these are all independent factors, right? If I wanted to, I could split all of this up and write everybody with their own little multiplication dot. Okay, it's all just straight up multiplication, so you only multiply what you can and just bring down what you can't. I don't have any other t's, I don't have any other v's, right? So that is my final answer. Okay, so multiplying monomials, very quick and easy. Okay, all right, now we're going to do a monomial times a binomial or trinomial. Okay, so you'll notice all of these. This is a monomial, right? It's one term. And then we're multiplying it times a binomial. Again, I know it's a binomial because now I'm starting to see plus signs. Well, we've been doing this since the very first week of school. Don't overthink it. If you saw this and I asked you to get rid of the parentheses, what would you do? You would distribute, right? So as soon as you have more than one term, that's when the distributive property is going to come into play. Okay, so I'm going to multiply negative 3 times x, which is negative 3x, and then negative 3 times 4, which is negative 12. Voila, that's all I got to do, right? All right, let's go to the next one. Again, this is all review. We've been doing this for a long time. Again, I have a monomial of 2/3, and I'm multiplying it times 3x minus 6. So as soon as I have a plus or minus sign, I now have terms and not just factors. So now I have to distribute. So I'm going to multiply 2/3 times 3x, which is, oops, I lost my other arrow. Sorry about that. Which is going to give us 2x. Again, if you want to use your calculator, you can type 2/3 times 3. And then minus 2/3 times 6, which is going to give me -4. Again, just feel free to use your calculator to do the multiplication of the fractions if you need to. And again, these are my final answers, right? Because I don't have any like terms right now. I can't combine x's with 4s or x's with 12s, right? So that's just my final answer. Now here, this is a trinomial, right? Which means I just have to triple distribute, right? The 2 has to go to every term inside the parentheses, right? So I'm just going to multiply everybody by 2. So 2x plus 6y minus 10z. And I can't combine any of those because they're not like terms. So that's my final answer. All right, so this is all review. We've been doing this since week 1. No big deal. Now we're going to start something new. Now we're going to multiply binomials times another binomial. Well, it's not that difficult, right? You just have to distribute more. So there's 2 methods to multiply a binomial times another binomial. Now I'm going to show you both with the exact same problem. Notice this is the same as this. So I'm going to do the same problem 2 different ways. And then I just want you to choose, right? Which one do you think works best for you? Okay. So there's pros and cons to both. So whichever one, like I said, resonates with you is the one I want you to use. Excuse me. All right. The box method is the method number 1. I love the box method. Does it take a little bit longer? Yes, right? But let me show you how this works. Sorry, my screen turned on me. There we go. So I have a 2 terms, that's a binomial, times another binomial. So if I'm multiplying a 2 term by 2 term, I'm going to make a 2 by 2 box. Okay? So here we go. So I'm going to make a box. And I'm going to make 2 rows and 2 columns because I'm multiplying a binomial times a binomial. So what I'm going to do, and it doesn't really matter which one you put where, I'm going to take my first binomial, 2x minus 1, and I'm going to write the 2 terms along the top. Notice I'm giving the negative to the 1, right, because it belongs with the 1. And then I'm going to take my 3x plus 4, and I'm going to put his terms going down the side. Again, making sure I give the 4 the plus sign. Now that you have, this is the setup for the box method. Now what we're going to do is we are going to multiply to figure out what goes in the boxes here. So I know that if I multiply 2x times 3x, that's going to give me the value that goes in this box. Well, 2 times 3 is 6, and x times x gives me x squared. Because remember, you have little understood ones, and when we multiply, we add the exponents. Okay, so 6x squared is what I get for that first box. Then I keep going. I'm going to kind of get rid of these arrows. Now I'm going to do the top right box. Again, you can do this in whatever order you want. So now I'm going to multiply -1 times 3x, which is going to give me -3x. Again, remember, I can only add like terms in math, right? But I can multiply anything I want, right? So multiplying a -1 times a 3x is going to give me -3x. All right, I'm going to move to the bottom left box. So I'm going to multiply 2x times +4, which is going to give me +8x. And yes, I'm going to put the sign in front of it because I want to make sure that I know it's positive. And then my last lower right box, I'm going to multiply -1 times +4, which gives me -4. So we've completed the multiplication, right? We've multiplied all the terms. Now we just need to clean up and we need to add all of these terms together. Well, I can only add like terms. Well, which out of all four of these, which terms are like terms? Oh, the 8x is an x term, and the 3x, or the negative 3x, is also an x term. The really cool thing about doing the box method is that your like terms will lie along that same diagonal. Now, do I have any other do I have any other x squareds? No. Do I have any other constants? No. Right? So when I write my final answer is going to be 6x squared. I'm going to combine my x's that lie on the diagonal. So negative 3x's plus 8x's gives me 5x's. And then, of course, my minus 4 constant in the corner. And this is my answer. Okay? So this is the box method. Let me see if I can. There we go. Okay, so multiplying to finish off the box and then putting your like terms together and just putting all your terms. Now, this should be the proper way you write it. And we haven't talked about this quite yet, but we always want our highest power. We always want our highest power first, then our second highest power, which is 1, and then our constants should always be at the back. So we definitely want it in this order, okay? If you put it in a different order, I'm not going to count it wrong, but it's going to make your life a lot harder later on because you'll have to fix it, okay? All right, so that's the box method. Okay, so method number 2 is called the FOIL method or double distribution. I'd rather just call it double distribution, but I'm going to go ahead and teach you FOIL because it's something that'll probably pop up and somebody might say out loud and you'll be like, I don't know what that means. So I'm just going to tell you that FOIL stands for first, that's the F, outside, which is the O, inside or inner, which is the I, and then last. First, outside, inside, last, right? That's what FOIL stands for. So basically, it's just telling you the order in which to distribute, right? So, hold on, let me scooch this up here a little bit. There we go. All right, so basically, I have 2 terms in this first parenthesis, and I have 2 terms in the second parenthesis. Well, you guys know that if this negative 1 wasn't even there, I'm right back to a monomial times a binomial. So I would distribute the 2x to everybody over there, right? The 2x has to get multiplied times both terms in the other parenthesis. And that's where the first and outside, 2x and 3x are the first terms. So I'm going to multiply 2x times 3x, which is 6x squared. Again, these are all going to look familiar because we literally just did this problem a second ago. Then I'm going to multiply the outside 2 terms together, which is the O in FOIL. So 2x times 4 is positive 8x. Please make sure you put the plus sign there and you don't just write 8x. You have to have a sign in front of the term to designate whether he's positive or negative. All right. Then we do have a negative 1. So again, kind of cross out the 2x as if he weren't there. If it was just a negative 1, then I would need to distribute the negative 1 to everybody also. So this is the double distribution. Everybody in the first parentheses has to get multiplied by everybody in the second parentheses. So we're distributing twice. Okay, no big deal. And that's where the inside last is coming from. These are my inside terms. So negative 1 times 3x is negative 3x. And then my last terms in each parenthesis are negative 1 times 4, which is negative 4. I lost my little parentheses here. So we double distributed, and notice at this point we have 4 terms, which you should have 4 terms. Oh, my arrow keeps disappearing, sorry. You should have 4 terms because you just multiplied a 2-term expression by another 2-term expression, and 2 times 2 is 4, right? But then you have to ask yourself, am I totally done? And no, you're not, because you have like terms, right? Notice these are the same like terms that were on the diagonal over here, but now they're sitting in the middle, right? So here's my like terms that I'm going to combine, right? So positive 8x minus 3x is positive 5x, And then, of course, I'm just going to bring down my 6x squared and my minus 4 because I don't have any other x squareds or constants to add those terms to. Okay, so it's basically, you're doing the same math. It's just a matter of, do you want to create the box and give yourself a visual representation of what's going on? Or are you totally fine with double distributing and just writing your math out in the 2 steps? Okay, so whichever method resonates with you is the one I want you to use. Okay, I'm probably going to hop back and forth just so I can give you a little variety. Okay, all right. There are 9 questions here that we're going to go over, and then we're going to do a couple of rectangle questions, and that's it. So feel free to pause the video and practice this skill, and then start the video and check your answers, or put me on like times 2.5 speed and make me go really fast. Just so whatever you need to do to make sure that you're really good at this concept, because this is like a big concept for Algebra 1. Because in a few days, we're actually going to learn how to do all of this backwards, right? So if we don't know how to do it forwards, we're going to be in big trouble trying to do it in reverse. Okay, so just giving you a heads up of what's to come. All right, here we go. X plus 2 times x times negative 1. I'm going to do the box method. Why not? Right? So here we go. I'm going to do the box method for these first 3, because why not? So I'm going to do x plus 2. So I'm going to split those terms up, and then x minus 1. And again, if you want to put the x plus 2 down the left side and the x minus 1 on the top, it doesn't matter, right? All right, here we go. Now we just need to multiply. X times x, x squared, right? When you multiply, you add the exponents, right? Please remember there's little understood ones right there. All right, upper right box, positive 2 times x, positive 2x. Lower left box, negative 1 times x, so negative 1x. And then lower right box, negative 1 times positive 2, negative 2. And then the cool thing is, your diagonal will always contain your like terms, which is a big reason why I like the box method, because it kind of helps check your math along the way. So let's see, I'm going to have x squared. If I add my like terms together, I'm going to get positive x, and then the minus 2. And there you go. Box method. All right, here we go. Let's try it again. I'm going to do the box method again for this one. Is that going to make a box? Oh, it did. Yay. All right, so let's see. T minus 9 and 2t minus 3. All right, let's get to multiplying. So again, these are understood ones. So 2t times t, 2t squared. When we multiply, we add the exponents. All right, upper right, negative 9 times 2t, negative 18t. Bottom left is negative 3 times t, so negative 3t. And then negative 3 times negative 9 is positive 27. And yes, I always like to put the plus sign in the box, right? Because I know that's the sign that I need to have in my expression of my answer. All right. Notice the like terms. Yay. All right, so I'm going to have 2t squared, because there are no other t squareds. If I combine negative 18 t's and negative 3 t's, that gives me negative 21 t's, and then the plus 27. All right, next up, again, I'm going to do another box method. Again, you don't have to do the box method. It's purely up to you. I'll change it up here in a second. So 4m plus 6, m minus 5. Right, we are multiplying. So here we go, 4m squared. Right, because we have 1 and 1. Right, you're always going to have a squared in that upper left box. You'll start noticing the patterns, right? This is going to give me positive 6m. Let's see, bottom left, 4m times negative 5. That's negative 20 m's. And then negative 5 times 6, negative 30. Again, my like terms are on the diagonals, so I'm going to be able to combine those and just bring everybody else over. So the 4m squared doesn't have any like terms, so he just comes over. 6m's and negative 20m's is going to give me negative 14m's, and then minus 30. Excuse me. All right, so there's the box method. All right, now I'm going to change it up a little bit. For the next three, I'm going to do the double distributing, or the FOIL, which is faster technically, because creating the box and labeling it and doing all that stuff, it does take a little bit extra time, right? But if you like it and you're comfortable with it, then it's worth the extra few seconds, right? All right, so here we go. I'm going to do FOIL, or double distribution. So my 3x, he needs to get distributed to everybody over there. So let's see, I'm going to multiply 3x times 2x, which is 6x squared. Again, remember, anytime you multiply an x times an x, you get x squared because you're adding the exponents. And then 3x times 3 is positive 9x. All right, then I'm going to distribute the positive 5 to everybody over here, which is going to give us positive 10x plus 15. So I double distributed, or FOILed, and then I need to clean up all my terms. And I notice, just like in the box method, right, I have like terms in the middle that can be combined. So when I clean that up, right, I'm going to get 6x squared plus 19 total x's in the middle, plus that 15 constant hanging on the end. Right? So it's two steps of math, no matter which way you slice it, right? You're either making the box, and then you are simplifying what's in the box, or you're double distributing and then simplifying the like terms in the middle, right? Either way, every single one of these should be a two-step math problem, okay? But there's a lot that goes into those two steps, so you want to be careful. All right, here we go. Number 5, I'm going to double distribute again. So the x has to get distributed to everybody over here, which is going to give me x squared plus 3x. And then my negative 3 has to get distributed. Pay attention to your signs. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. Again, it's going to happen every single time, right? I have like terms in the middle. Now this one's pretty special because what do you notice happens with our like terms? Yep, they cancel out, right? Positive 3x's and negative 3x's gives me 0 x's, which means there's no x's left. So that means I'm just going to bring down my x squared and my minus 9. I don't have an x term in the middle because they all canceled each other out. Okay? All right. Now this one is not so friendly, right? But we're still going to do it the exact same way. If you want to use the box method here, you can. But I'm just going to do FOIL, or double distribute. Just be careful. So I'm going to distribute the negative 5x to the 6x squared and the negative 7. All right, so just be careful because now I don't have just x's. I have x's and x squareds. So when I multiply negative 5x times 6x squared, I'm going to get negative 30x cubed, right? Because I add the exponents. So I have 3 total x's, so x cubed. And then negative 5x times negative 7 gives me positive 35x. All right, then I'm going to distribute the positive 1. Well, that's a much easier distribution, right? If I multiply everybody by 1, I just get what I started with. So 1 times 6x squared is 6x squared, and 1 times negative 7 is negative 7. Now, you might be asking yourself, what we have here, I don't have any like terms, right? The stuff in the middle, those aren't like terms. One's an x and one's an x squared. Well, what do? Well, x cubes can only be combined with other x cubes. I don't have any. X's can only go with x's, x squareds with other x squareds, and constants with constants. So I have no like terms whatsoever. So my answer technically is this, except I really, really want my answers to be written in decreasing exponential order, right? We'll talk more about this later, but I want the highest power written first. So negative 30x cubed is the term with the highest power. And then the next highest power would be the positive 6x squared. So I'm actually going to write him next. And then after x squareds would come x to the first, which is just the x's. So plus 35x, and then my constant at the back. So this is how I would like you to practice writing your polynomials, right? Always in decreasing exponential order. Okay. If you left your answer like this on a quiz or whatever, am I going to count it wrong? No, right? But we want to get in the habit of every time we see a polynomial that we write it in this nice, pretty exponential decreasing order. Okay. All right, let's go do a few more. We're almost done. Now, number 7. Okay, I taught every math class from algebra to AP calculus and beyond. And it's so funny that it doesn't matter what math class I've taught, every math student makes this silly mistake every time. So you want to be really careful, because we just learned that if you have a power on the outside, it goes to everybody on the inside. But that's only if that all you have inside is factors, right? That little exponent rule that we learned only applies to factors. And this is not factors. These are terms, because I have a plus sign in there, which means you cannot, I repeat, cannot just distribute and square those two terms. That does not work. You are not allowed to do that, because in this case, you have to ask yourself, well, what does it mean to square things? Well, squaring things means to multiply them by themselves. So whenever you see x plus 2 squared, you actually need to write it out twice, right? That is what x plus 2 squared means, is x plus 2 times x plus 2. Well, awesome. Now I'm right back to all these other questions, right? So I'm going to go ahead and use the FOIL method. So I'm going to distribute the x, which gives me x squared plus 2x. Then I'm going to distribute the positive 2, which gives me positive 2x plus 4. And you'll notice the like terms are back. All right, I've got 2x and 2x in the middle. So those are like terms, and we'll be able to combine them, right? Which gives us a final answer of x squared plus 4x's total in the middle, and then bring down that plus 4. So hopefully you can see why it would be wrong to just square the two things inside, because if you square, you're just going to get x squared plus 4. So you're missing out on all the goodness that's happening in the middle, right? And we don't want to lose out on that, because that's a third of our answer. Okay. All right. Number 8 is the exact same, right? Oh, 3x minus 1 squared. That means I need to write it out twice. And then FOIL, or double distribute, or box method. Again, whatever you're comfortable with. So I'm going to distribute the 3x over there. 3x times 3x gives me 9x squared. 3x times negative 1 gives me negative 3x. Then I'm going to distribute the negative 1 multiplier. So that's going to give me another negative 3x. And then negative 1 times negative 1 gives me positive 1. And you'll notice we have the like terms in the middle. So and those don't cancel each other out, right? Be really careful, right? So when I add negative 3x's to negative 3x's, I get negative 6x's when I combine those. And then I'm going to bring down my 9x squared plus 1 on the outside. And there you have it. Voila. All right. Number 9 is kind of a little challenge question here. This one is a binomial times a trinomial. So we're still going to double distribute, but now the x has to go to, we're kind of triple distributing, I guess, right? Because now the x has to go to 3 terms, and the 2 has to go to 3 terms. Now that's a lot of distributing, so I'm actually going to do the box method here. Anytime I get bigger than a 2 by 2, I use the box method, right? So if it's 2 by 3 or 3 by 3, I like the box method. So here we go. But now that it's a 2 by 3, I need a 2 by 3 box, not a 2 by 2 box. So I'm going to do 2 columns and 3 rows. You could, of course, go vice versa. All right. So I'm going to put my binomial on the top just because I made it 2 columns. And then I'm going to put my trinomial down the side because I made 3 rows. There we go. And then I'm just going to multiply to get the boxes inside. So 3x times x is 3x cubed, right? Because again, there's understood ones. And then this is going to give me positive 6x squared. And then negative x times x is negative x squared, because it's negative 1 times 1, right? And then x times x, which is always x squared. And then this is going to give me negative 2x. This is going to give me positive 2x. And this is going to give me positive 4. All right, now I hope you notice something really cool is happening, right? Do you guys notice how my like terms are still on the diagonal, right? Again, notice I don't have any other cubes because he's his own little diagonal, and I don't have any constants because he's his own little personal diagonal. But I do have 2x squared terms and 2x terms, and I'm going to be able to combine those. So when I clean up all this mess, I have 3x cubed. Then I'm going to add my x squareds together. Negative 1 plus 6 is going to give me positive 5x squareds. And then positive 2x's minus 2x's, well, they disappear. So I actually don't have any other x's. And then plus 4. So if one of your terms cancels, then just leave it off. No, don't write any x's whatsoever. And there you have it. All right, so the box method is great for kind of organizing your terms so you don't get lost in all the distributing, right? If you want to do the triple distribution, that's great too, right? You'll just have 6 terms floating around on your paper there, and you'll just have to combine your like terms, okay? All right, our last 2 questions really quick is just representing what we just did and that it pertains to the area of a rectangle, right? So right here, I know this is a square, because the dimensions are the same, right? It's 4z plus 3 times 4z plus 3. Well, if I want to find the area of a square or any rectangle, right, it's just base times height. So I know if I want to find the area of this square, I'm just going to multiply my dimensions. So my base is 4z plus 3, and my height is 4z plus 3. All right, so when we're multiplying binomials, we're actually finding the area of the rectangle being created by those binomials. Okay, so we'll start doing some word problems here pretty soon. Now, that's literally all you have to know, right? And then we're right back to every single one of these questions, right? They're all the same. But I am going to be multiplying 4z plus 3 times another 4z plus 3. All right, so here we go. I got to take my 4z. I'm just going to do the double distribution or FOIL. So 4z times 4z is 16z squared. And 4z times positive 3 is positive 12z. All right, now I'm going to distribute my positive 3 over to both terms. So I get a positive 3 times 4z, which gives me another 12z's. And then 3 times 3, which is 9. And then, of course, I have my like terms of z's in the middle that I'll be able to combine. So our final answer would be 16z squared plus the 24 total z's in the middle, and then my constant of plus 9. And that would be the expression that represents the area of the square. Okay, let's do it one more time, and then we're done. So this is a rectangle. Rectangles also have an area formula of base times height. So we're going to do the exact same thing that we just did, right? So, my base is 6x plus 11, and my height is 4x minus 9, or vice versa. It doesn't really matter which one you're calling the base and the height because we're multiplying anyway, and order doesn't matter when we multiply. Okay, so here we go. I'm going to take my 6x and distribute him to everybody over here. So let's see, that's going to give me 6x times 4x. That's going to be 24x squared. And then 6x times negative 9, negative 54x. Then I'm going to distribute my positive 11. That's going to give me positive 44x's minus 99. And then, of course, I have my like terms in the middle that I'll be able to combine. here in just a second. I'm going to go ahead and just write my final answer though down here. So my 24x squareds, and then negative 54x's plus 44x's, that's going to be negative 10x's, and then bring down my negative or minus 99. And there you go. That's the expression that represents the area of the rectangle. Now, I know those aren't like answers because I don't know what x is, right? Technically, x can be any number it wants to be as long as it produces a positive side length, right? But this would be the area regardless of what value I picked for x. Okay? All right. I hope you guys feel comfortable with multiplying your binomials. Like I said, here in a couple of days, we're going to learn how to do all of this backwards. So basically, I'm going to give you this, and you have to tell me what two binomials did we multiply to get that in the first place, right? So that takes a little bit more work, but as long as we feel comfortable going forward, right, and we're really good at this skill, then going backwards isn't going to be all that bad, okay? All right, let me know if you guys have any questions over any of those problems, and hopefully your homework goes really smoothly. All right, bye.